All right. Lesson 1 in chapter 2 is on forces. And we started out, we read through all this. Now we're going to talk about it. Forces. What a force is, it's usually measured in newtons. Okay, that's what they call it. So if you have this water bottle sitting here, it's not moving. Okay? In order for it to move, you need to have a force act on it, which is this. Now, it would be measured in newtons. Also, for something to sit there and not move, it has equal forces on it. Okay? So there are forces hitting from the sides, from the bottom, from the top, that's holding it still. Okay? This is one that you don't sit and think about because you don't really think about it. It's like, well, it's just sitting there. So there's no force. No, there is force. Force is acting on it's equal all the way around it. That's why it's not moving. If you've ever done tug of war, okay, you get two teams and they're sitting there pulling on the rope, and there's a ribbon in the middle that hangs down, and that ribbon is not moving. It's not moving that way or this way. The forces are equal. And so that ribbon doesn't move. Okay, even though you're exerting all this force, the forces are equal. You got 3 people on one side, 3 people on the other side. They're equal strength. So when they're pulling, it's not moving. Okay, that's just to show you that. Forces are going to act on objects. They are what, bless you, they are what is making it change, speed up, slow down, okay, of an object. And we're going to go into that even more. The first one that they talk about is contact forces. One of the ones that they talk about with it is friction. I watched a kickball game the other day. Time to ruin kickball because they're out there doing science. First of all, you have one person exerting a force on the ball to roll it in. Then you have another person exerting a force in the opposite direction, kicking it out. Now, every once in a while I saw Ryan kick one way out there, but by the time I think it was Ari got to it, the ball had stopped. Why?
Because friction on the grass.
Friction on the grass has slowed it down. Okay? Now, sometimes you guys have noticed when you're playing on the court and you kick it down that way, it'll roll a lot farther that way than it does if you hit it up towards the shot. Why?
Less friction.
No, not less friction.
There's a hill and the grass isn't as soft, long and soft.
Right. You're kicking it up a hill. You're making the ball go upwards where something is pulling it down. What?
Gravity.
Gravity. So you have gravity pulling it down, a force, and you're trying to go up a hill. Okay? You have the friction of the hill plus gravity. When you're kicking it downhill, you have friction, but you have gravity pulling it rather than pushing. Okay?
Wait.
So when it's going downhill, gravity is pulling it down the hill. When you're kicking it up the hill, gravity is pushing it from going up the hill.
Oh, the down is pushing it down.
Pushing it back. You roll a ball up the hill. It's only going to go so far. You put that same amount of force and go the opposite direction down a hill,
It's gonna go farther.
gravity's pulling it down. Gravity's pulling it in either direction. Okay, so if you're kicking it up the hill, gravity is pulling it back, pulling it down when it's trying to go up. Okay? Does that make more sense?
When it's pulling it down.
When it's going down the hill, gravity's pulling it to make it go down faster.
Oh, look.
Okay?
It falls.
Now, but you have friction. Now, one of the things I've talked about in here is if you take your shoes off and you got your socks on, and you go in here and you go sliding across the carpet, you're not going to go anywhere. But if you go out here on this surface, no. If you go out here on this, in the hallway, there's less friction out there. And so less friction is going to mean that you're going to slide further. Now, we talked about it with slip and slides too. Because if you don't put water on a slip and slide, and you go try and slide on it, you may slide a little bit, you're not very far. If you put water on it, it's going to create less friction. Then if you take some baby shampoo, because it's no more tears, and then if you get it in your eyes, you're not going to be blinded. If you put the Dawn's dish soap on it, you get soap in your eyes, it's a mess. Put the No More Tears baby shampoo, it's a soap, you put that on, then you go slide, it makes you even less friction. You're gonna go the farthest with that.
Less friction.
Less. Now, this works for solids, it works for liquids, okay? In the book, we read about submarines, how they go. There was once the U.S. in the Olympics, they have a sailing boat. And what they did was they put a lot of science into it to figure out how they could get this boat to go faster so they could beat the other nations that they were racing against. Well, they went and they studied the shark. Okay? They studied an animal that actually lives in the water, and they studied the shark. The shark's skin is actually set up to have the least amount of resistance. That's why when they go to attack, that they can go at such a high speed, especially the mako shark. Okay, they are supposed to be the fastest of the sharks. So they studied the skin of it, and they found out the way it was made up and everything, and they went and made this skin layer, put it on the bottom of these boats, and raced them. Now, they had a normal boat that they had been racing, and they had another one that they just made with this new shark skin underneath. They raced them, and normally the race takes like 6 to 8 hours, I think it was. I'm not sure on it. But the one with the shark skin finished almost an hour ahead of the other one that was a normal racing one that they had. It was that much less resistance, less friction in the water. Okay? So water does cause friction. Okay? And we are talking about it with Hurricane Zeta right now. Because with that hurricane, once it goes over land, it dwindles down. It weakens because it's running into the friction of the land. That's why it was a Category 1 last night, went over the Yucatan Peninsula last night, became a tropical storm again. Now that it's starting to get back out over the Gulf of Mexico, it should have less friction to where it can speed back up to a hurricane, okay? So there you have the wind and the water, okay? Then they also talked about the non-contact forces. These they talked about gravity, and they talked about magnetism, magnets, and electricity. The electricity part is when you would take some batteries and you could wrap them around wrap wire around a nail, and you can magnetize that nail. Because what you're doing with electricity is forcing all of the atoms that are in that metal to divide up and go face north and south. So all of them would be facing north and south. And once they're all set up that way, it becomes a magnet. That nail becomes a magnet. Electricians will do this also with their tools, especially a screwdriver, because if they're having to go down into a place where they can't stick their hand, but they have to have a screw that they have to screw it in, what they're having to do is make their screwdriver into a magnet, so it will hold the screw on the end of it, and they can put it down in and then screw the screw in, and it's in there. Okay? I know that over the summer we have a screwdriver that's like that here. I went and tightened all the legs on your desk. Okay? Some of them had screws that were in the legs, and in order to get them out, I can't stick my finger in there. So instead of taking off the legs and having it drop out, I just had it go to where the hole was, and I'd have a magnet and I'd pull it right out. It didn't take that long to do that, okay? But that was how that was used. These magnetic forces are done without touching,
But how? The force.
okay? There is no force whatsoever. I'm gonna let go of the pen, but
Oh my god.
what took it, Luke? Gravity.
Push the pen down to the floor.
It pulled it down, okay? This was all I did was just let go, and it fell. I didn't push it or anything, make any contact with it, okay? No other contact was made with it, but gravity pulled it down. Gravity is one of those non-contact forces. The other one is the electric and magnetic. Magnetic means that it is pulling it. At the very beginning, on page 60 and 61, up at the top, you have the picture of the magnet on one side of a piece of cardboard or board, whatever it is. On the other side, you have something that's metal, and it's floating, okay? And until it gets out of that force, okay, it's gonna stay, it's a non-contact force that's holding it up. Because as long as it's within that magnetic field, yes, it will stay up. Now, the further and further you get away from that magnetic field, the less force it's gonna have on that piece of metal, and it will drop off. Now, here on Earth, your weight is based on the pull of gravity. In other words, gravity likes me more than it likes you.
What?
That's good for me. I don't care.
It's pulling on me more than you.
Wait, isn't it like?
In other words, what, Luke? Go ahead and say it. No, what did you say? I'm heavier. Okay? Christian said it. Christian, you get credit. Sorry, Luke, you're dropped from the list.
Me, I'm good job.
That's why it's heavier.
But when you talk about your weight is actually the the pull of gravity. If you get in an airplane and you fly to Colorado, Colorado's a mile high up in Denver, okay?
Means that you get here, right?
But you get on the plane here, you weigh yourself. Then if you get off, if the pilot allowed this, Christian, maybe your dad would allow it, take the scale with you, and when you're flying at 30,000 feet, weigh yourself, you will have lost weight because you're farther away from the source of the gravity, and you will weigh a lot less.
So I
Yes.
don't want that.